Hi, I'm Rahul. Today I'll be talking about the sun compass of the European starling. For a little bit of background, many animals utilize the sun compass to properly orient themselves towards the food and specific migratory directions, and these animals include all the ones that you see on the screen. So, researchers knew that the European starling was a daytime migrant and a daytime forager, so they hypothesized that they could be using the sun. So basically, a sun compass just uses the sun to orient themselves towards the correct direction. And this is based on the fact that the sun rises at 6 a.m. in the east and moves 15 degrees per hour through the southern sky and eventually sets at 6 p.m. in the west. And one thing to note is it never actually passes through the northern sky. To test this, uh, researchers first trained birds to find food in an outer ring of bins, and the specific direction they chose to train them in was the southwest. And they switched up the orientation of the bins, just so they knew the birds weren't using visual cues to go to a specific bin, um, and make sure they were actually using sun compass. So the research to test this, the researchers did something called clock shifting the birds by placing them in darkness indoors and manipulating the time the sun rose by turning the artificial light on at different times. Um, and so what they did was they clock shifted the birds 3 hours earlier and turned the light on at 3 a.m. because they knew that if these birds were using a sun compass for orientation, these clock shifted birds would make predictable mistakes. So what they found was that the birds that were clock shifted 3 hours earlier were tested at 9 a.m. And since they thought they were awake for 6 hours, they thought it was noon, and they made and to find this bin in the southwest, they would make the turn 45 degrees to the left, or 45 degrees to the right. My bad. And actually, they were in the southeast and made the predictable mistake of going south instead of southwest because they were clock shifted. So I think what would be helpful would be going through a question from quiz 8 to try and understand this concept. So the question asks, suppose you are studying its sun doubles and cardinals and trying the cardinal to find food in the north of an outdoor orientation. You clock shift the bird so the lights come on for it at 9 a.m. real time. You take it outside and test it at noon real time. What time does the bird think it is being tested at, and where does it think the sun is? So you have to be careful with this question here because the mention of the food in the north is actually not relevant to this question at all. So that what time does a bird think it is being tested at? Well, it's clock shifted at 9 a.m. and at noon. So it's been awake for 3 hours. It usually wakes up at 6 a.m. 3 hours later, it thinks it's 9. And then you just have to correlate this with where the sun is. So where is the sun at 9 a.m.? It's in southeast. And you just need to pay attention to specifically what the question is asking. Now we can look at an example that I made up. So now suppose we took a bird and we trained it to find food in the north. We clock shifted the bird so that the sun rose at noon, and we take the bird and test it out at 3 p.m. real time. This first question is the same as the last question. What time does a bird think it's being tested at? So it's clock shifted, so it wakes up at noon. We test it at 3 p.m. It's been awake for 3 hours. Normally it wakes up at 6 a.m. 3 hours later, it thinks it's 9 a.m. And where does it think the sun is? Well, where is the sun at 9 a.m.? It's in the southeast. Now, for the second question, we actually do need the information about the food in the north. So the question asks, what direction will the bird turn to orient itself towards the food? And so I'll use this to explain. we established that it thinks it's 9 a.m. and it's in the southeast. And we want it, and we know the food's in the north. So it's going to take the shortest path towards finding the food. And that would entail a 135 degree shift to the left. And we know that because east to southeast is 45 degrees. Like each of these turns is 45 degrees. So you have 1, 2, and 3. 45 times 3 is 135. You could also think of it as north to east is 90 degrees. And then east to southeast is 45 degrees, and just add that up. What it should do, because it's actually here, is it should turn 135 degrees to the right. So since it's clock shifted, it will turn in the wrong direction. I hope that makes sense. Thank you for listening.